One proportion z-test, also called as binomial proportion test, is used to assess whether a proportion P1 is significantly different from a hypothesized value P0. Let's understand this topic from an example. From a CDC website, we can find that the overall number of deaths in US from March to September 2020 is about 1.87 million, while the US population is 331 million. Death rate is 0.57%. We also know that the death rate from the same period in 2019 is 0.51%. Since there is a COVID-19 pandemic during this time, we would like to test if the overall death rate in 2020 is significantly higher than the rate in 2019 in same period. Another example, some students are interested in estimating what percent of professors in their department watch Games of Thrones. They think it should be about 20%. They then ask each professor. It turns out 17 out of 62 professors watch this show. Is this estimation correct? We can imagine the data is a bunch of yes and no. We are going to practice analysis. Use the second example. We need to make a small table in Excel before doing analysis. There are two ways to arrange the data. First, we can put the data as one professor a row, or make a summarized data like this. Let's go to SAS Studio to analyze these two different forms of data. As we did before, access the SAS Studio. After log into SAS Studio, we will upload the Excel data. You can see the height data we uploaded last time is still here. But the SAS data named work import that come from the height data last time is disappeared from the work folder. Here is the important things to remember. Any data imported into SAS work folder will be deleted after we close the SAS Studio. If anyone interested in, I will make another video to talk about library folders, moving data sets from different locations, and how to make a permanent SAS data. Let's upload the data. Highlight the research folder and upload. First, let's upload one proportion data. And the summarized data. One proportion sum. And we'll import the data by right-click and import data. The new window pops up. The system again generates some code. Remember, we have to click on this little running person to execute the code to import the data. Now the data is imported, and it's named work.import. If we go to the library, under the work folder, you can see the data import is in here. Now let's import another data. The second one proportion sum data. So there's another one work.import1 generated, which is under the library, my libraries. By double-click the data name, the data window will pop up. We can see what data looks like. We can also customize the data name. Now let's go to the task menu to do our analysis. Double-click on one-way frequency. Analysis window pop up. And in here, we will choose our data variable and select the options we need. Let's first choose the data. Work import. This is the data we imported from one proportion and data.
the variable we will choose what show. That has a bunch of yes and no. Yes comes first in the order. In option, we will suppress the plot because it's not necessary for this kind of analysis. In the statistic part, we will use the asymptotic test. The noun is not 0.5. Remember, we are testing if the proportion is 20% for the professors who watch show. So 0.2 is a noun value. And also check the exact test if you want. It can output additional exact test result. If you have very small sample size, the exact test is more appropriate. And we don't have to include any missing value. Okay, after execute the code, we can see that the binomial proportion in here is for what show equal no. That is 72%. But we want to compare if the what show equal yes. That is compared with 20%, not no. So we have to go back to our option. It is important in options row value order. This is to tell SAS what proportion to calculate, yes or no. By default, it will pick up no because of alphabetic order. We suppose we can use descending frequency option, but I think there's maybe a bug in the system and didn't work. Luckily, our data have yes in the first order, so we will use order appearance in dataset. Now we run again. The correct results show up. The binomial proportion shows percentage what show equal yes is 27.42%. Now let's do the other data. Go to the double click one way frequency again, and new window pop up again. Let's choose the data. The second data is import 1, and choose the variable what show, which is yes and no. Now we need to click additional row and add the variable number as a frequency. It represents the frequency of each yes and no. Go to option, press the plot. In statistic, asymptotic test, this one, 0.2, choose exact. Don't forget, we have to make sure that the row value order is the order appearance in the data. Okay. From here, you can see it also have the what show equal yes proportion tested, and the results in here is two-sided p-value is 0.1442 and the exact test 0.1990, which is close. And from the first data, we have exactly same value, same results, p-value showed up. So no matter what way you arrange the data, the result is same. You choose the appropriate method. Now you can output your data into Word file, RTF file, and open them in the Word file.
Here's how we report the result. First, describe the data and the percentage, then indicate what statistical method we used, and the final test result, and the p-value. Okay, that's for today. See you next time.